I'm going to do a demonstration here of some of the technology that we have to offer, how we can integrate with your existing systems, and really kind of just talk about this product lifecycle digitalization, the digital thread of information, you know, when we're referring to these kind of catchphrases, if you will, in modern times. So what you'll see up on the screen here, first and foremost, is really where this digital thread begins, right? I'm actually in a CAD system here currently. So the primary focus of this product digitalization is to basically remove the need to push information through, I don't want to call them archaic, but tools that have been in existence for a long time, right? Do I have a 3D model in which I then generate 2D prints to then send to sourcing and then manufacturing? And it's really, as Craig mentioned earlier, this very serialized process. So if we have a digital twin of this product in our modern CAD systems now, how can we then leverage both that geometry and really all of the data that could be extracted directly from that digitalized product? That's really where aPriori can come in and play a large role in all of your organizations and really connect the dots between some of these departments. So first and foremost, I do like to showcase that, right? You can see that right up top here, aPriori is an integral part to these modern CAD platforms. You have the ability to push data straight from that design engineer's tool right into aPriori. We can do this both in sort of a manual version, such as clicking on a button and physically launching an application. And we can take this all the way to the extent where the aPriori tool is actually just interacting in the background with specific triggers, meaning that your team can actually generate manufacturability information, should cost information, ideal routings for particular components, in virtually a completely automated state. Now, from this CAD system, right, I'm going to shift gears a little bit right to the aPriori platform itself. So, right, this digital thread, this digitalization of the product lifecycle really starts with that CAD file, and now I just need more information. So moving into looking at this product from both a design engineering standpoint as well as a sourcing standpoint, how is it that aPriori can play a role here? So as I mentioned, we directly integrate with that file. So from here, I can immediately look at things like assemblies and dig right down into individual products found within the product being developed. Now, the aPriori model, it only needs a few user inputs to generate a lot of data-rich content. In this particular example, we're looking at potentially die casting this component. We're going to source this at really whatever region we're interested around the world. aPriori is able to overlay local data such as labor rates or overhead rates, even available machine types for specific regions around the world. We're then coaching the tool as to what is this product made from and what's that annual volume. With just a couple of these basic inputs from the user, aPriori does a couple of things. It actually extracts the geometry of this part and predicts an optimal routing. So we can actually see explicitly how this part is going to be manufactured. We can see that complete start to finish, inclusive of the machining of that component. And then we can even see things relative to the actual cost roll-up of the component, right? We can see that the material is playing a really significant role in this particular part. Over 70% of the cost is simply driven at the raw material level. Now, because aPriori is again, this digitalized version of this model and the digital thread still intact, we haven't actually taken this 3D CAD file that lives in our computers. We haven't generated a 2D print and then sent an email for an RFQ. We're basically able to replicate a should cost model right within the tool. And the biggest benefit here is we can now iterate on this as well. So for sake of example, if we're focused on material for this particular item and we're looking to reduce the cost here, what are some things that could play a large role in the overall cost of a product? Well, in this particular case, materials number one, and then things that are downstream of that, you know, things like the overhead rates or the labor portion that are going into that product, and in turn, maybe trying to optimize something like cycle time. Within aPriori, we can save scenarios of items and basically iterate through different potentials from a manufacturing standpoint. In this case, I wanted to look at a couple of different materials that this part could potentially be made from. So we're looking at a few different versions of aluminum, magnesium, and a couple of zinc options here. And because aPriori has all of the calculations really in the background that it's doing, we can actually sort this and say, okay, I want to understand what is the overall cost of this component in these other materials, but I'm also interested in the cycle time performance here, right? I don't necessarily want to go to a particular material that's going to take longer to cool from an injection or a die casting standpoint, and I certainly don't want to increase my machine cycles because I'm already up against the fence here from a throughput perspective. So I really want to optimize not only cost, but things like cycle time as well. Stepping into another part on this particular assembly, just looking at specific items and then iterating through not just materials and things relative to cycle time, but really allowing your teams to ask what if more often, right? If I back up and we look at this first image here, this original cover was actually designed as just an aluminum plate, right? We're just simply machining this from a solid stock, but having a tool like aPriori allows your design engineers and even your sourcing teams to simply say, I've got a part in question. I think there may be a better way to manufacture this, but I don't have a way of quantifying it. So what we can see here is rather than having to, again, redesign the component, send it out for RFQ, and really kind of play the traditional game that we play today, what if we just were to look at a digital simulation of this? So I want to take this part and I want to cost this as a plastic injection molded component rather than a stock machine component. Just by doing that, again, aPriori is going to reassess that from a manufacturability standpoint and come up with not only cost estimates, but things relative to cycle time, design guidance, right down to the tooling cost associated with that part. We can then immediately stack these things side by side. We can start to iterate in many different ways in the sense that this particular cover, we first looked at a stock machine component. Now we're looking at a plastic injection molded part. And we can see that we're able to not only reduce cycle, but we're able to dramatically reduce the cost here. Right out of the gate, this could potentially just be a directional exercise, right? Maybe we want to cost this component as a stock machine component from billet versus die cast versus plastic. Help our design engineers understand which would be the optimal process to focus on, and then start to shift the design of that component to best align with that particular process. One additional thing that I do like to highlight is I kind of pointed out those digital factory locations, areas around the world that we're able to cost components in. So just as I was illustrating, we can iterate through alternatives from a material standpoint, we can do the exact same thing for different regions around the world. So what I've done here is I've looked at actually identifying the cost of these components through five different tiered suppliers that we have, sort of our primary go-to low-cost regions and supply base. And for the components in question, we can quickly see that we, basically a total cost here, but we can quickly see that Thailand, Vietnam, and China are pretty well aligned for an overall cost standpoint, and that might be where we want to focus our efforts here. But we can quickly see due to the present tariffs that we're seeing over in China right now, that this logistics cost is just simply making this component non-competitive in that region. So not only are design engineers and sourcing teams able to look at iterations on material types or even just entire process group types, in this particular example, we can matrix cost these parts through virtually as many regions around the world as necessary, or getting more specific with some of your strategic supply base to best understand where is the optimal plate or the optimal supplier to source this part today, right now, right? Not 6 months ago, not 2 years ago, based upon our historical data. I need some real-time data to help you react to the changing markets here. Now, the last thing I do like to showcase is what we were just kind of going through was an individual assembly made up of individual components and kind of looking at the one-by-one details relative to those parts. Something that aPriori does is because we're able to look at all of this data and we are tied to that digital thread, once we step this up a notch and we start looking at actually automating some of these results, we can produce a tremendous amount of data in the background for your teams to then effectively filter through and understand where are some of the pain parts for whether that's product development or whether that's in the sourcing field. This particular example here is actually taking a current project and letting aPriori basically do its thing. It's going to analyze components for what are we currently paying today for these components, right? We're cutting POs for parts right now versus after doing that mechanistic costing, what does aPriori think these components should cost based upon various inputs such as material and region and volume? And then finally highlighting the potential for our sourcing teams to go after. Now, this example here, I personally work with a lot of pre-sales customers and clients, and I will say that this is an extremely common result. What we typically see is there's a few parts over here to the right where we're effectively saying the price you're paying today is actually really well aligned with that should cost, right? You're getting a very fair deal for that component. And it's encouraging to see some of them under the line, and it's really encouraging to see a nice flat trend line here because it just means that you're well aligned with your supply base. But something that we always see when we look at a large group of components, assemblies, product lines, or even commodity groups is we are going to have some outliers, right? These particular components here to the left, we're paying around $35,000 for the purchase lot here. We should be paying no more than $16,000 according to aPriori's mechanistic cost model. What this really helps your sourcing teams do is pinpoint those outliers and think of this as a fish finder, right? We don't need to spend our time on these components down here. The overall spend is relatively high, but there's really not a lot of wiggle room for what we could be purchasing that part for. So this really lets us kick things up a notch, filter through large arrays of data, and really help us understand where the opportunity is from a sourcing standpoint. We actually have very similar tools that are used on the design engineering side as well that filter through things like manufacturability issues. If I'm looking at 150 stock machine components, I want aPriori to flag the components that are most challenging for my team to manufacture and really help either drive that NPI cycle to a more effective part right out of the gate from a sourcing standpoint, or even a VAVE standpoint, where are some of the opportunities on the current products that we're making today.